Alright, good day everyone. For today's lesson is we're going to discuss the methods in designing a doubly reinforced beam using WSD. So we're going to do that by solving this example here. So let me read to you the problem number 3. A simply supported beam 8 meters long is to support a total load of 28.8 kN per meter. It is desired to find the steel reinforcement at the most critical section in bending. The cross-section of the concrete beam is 400 by 600 with an effective cover of 60 mm for reinforcement. F prime C is 21 megapascal, Fs is 140 megapascal, and N is equal to 9, or the modular ratio is equal to 9. So determine the required number of 32 mm diameter tension bar and the required number of 32 mm diameter compression bar. Right? So this is the problem. So ang tanong po dito na pa-require sa atin ay ilang 32 mm diameter ang kinakailangan natin sa tension side at ilan din yung 32 mm diameter na bar para sa compression side. Okay, so paano natin ito solve? Okay, so first step natin, like we discussed on the previous examples, we need to compare or to determine first if our beam will be designed as a singly reinforced beam or a doubly reinforced beam. We can do that by comparing the actual moment to that of our balance. Okay, so we need to compute the values of these moments. So either of the two ang unahin mo, okay lang. No, basta ma-compare natin sila. So unahin ko dito class is the actual moment. So yung actual moment natin na kukunin natin as the problem says, and when we design, dapat yung inuuna natin yung sa may critical section. Although we design all of a parts, no? Or section on our beam. Okay, so kailangan natin i-design. Pero dito, ang problem is yung sa critical section. Ibig sabihin, kung nasan yung maximum moment po natin. Okay? So, simply supported yung beam natin. Alam po natin, pag simply supported beam, okay, nag-occur yung most critical section or maximum moment at the midspan. Pag uniform distributed load. Okay? So, we have here the formula for the maximum moment sa midspan, which is equal to W L squared all over 8. Okay? So, we have a W of uniform distributed load na 28.8. Gaya po ng problem. Total load na yun, no? 28.8. Gaya sabi ng problem. Times L squared, yung length po natin, yung span natin is 8 meters all over 8. So, we will have a maximum moment at the midspan of 230.4 kilonewton meter. Okay? So, meron tayong moment actual. So, next po ay kukunin natin yung balance moment. So, we were going to determine the balance moment by first determine or solving the K balance. So, K balance, we have here the formula for that. We have the allowable stress of concrete all over the allowable stress concrete plus the allowable stress steel all over N. Okay? So, FC here, the allowable stress sa concrete, we have the formula for that, 0.45 times F prime C. So, the F prime C, which is given That is 21 megapascal. So 0.45 times 21, we will have an allowable stress sa concrete na 9.45. Okay? Ano ba? Then, for the steel naman, binigay niya FS 140. So, lagay po natin lahat ng value sa ating formula and we will have an answer of 0.38. Okay? Or 3778 approximately is equal to 0.38. So, if meron tayong K balance, next is we're going to determine the X balance or yung KD balance. So, X balance is equal to K times D. Anong K yung gagamitin natin? The K balance. So, that is 0.38 times D, which is 540. Ano po na natin na-compute yung 540? Okay, it is simply the total height minus the effective cover. Okay, so as you can see, effective cover, okay, it is the distance from the edge of your concrete to that of your steel, no, the centroid of your steel. Yan yung tinasawag na effective cover natin, which is 16. So therefore, okay, para makuha natin effective depth is the distance from the extreme compression fiber up to the steel reinforcement. Ito po yung ating concrete, no? Effective area ng concrete natin. So from here to the centroid is yan yung effective depth. Para natin makukuha yung effective depth, it is the effective cover or the 600 minus the effective cover. So we have 540 as you can see here in our equation. So we will have an answer of 205.2 millimeter as your X balance. So after solving for X balance, okay, we can now solve M balance. So moment balance is equal to C. Ano yung C? Ulit, class? Okay, very good. C is the compressive force. Okay? Times, what is D minus X over 3? Yan po yung distance between the two forces C and T. Tama? Okay, so lagay natin yung mga values dyan. So C, okay, like we discussed before in problem number 1 and 2, ang C po natin is equal to 1/2 times X times F prime C times B. Where your X here is the value of our X balance. So, lagay mo lahat po ng value na nandun. Okay, so 1/2 X is 205.2 times FC, which is 9.45, times your B, 400 po yun, times D minus X over 3. Okay, then we don't forget to multiply it by or divide it by 1,000 square. Bakit natin i-divide ng 1,000 square? Kasi po yung lalabas na sagot dito is Newton millimeter. So, gusto natin na sagot is kilonewton meter. Kasi i-compare natin ngayon sa actual moment na merong unit na kilonewton meter. Okay? So, we will have an answer of 182.9 kilonewton meter. Okay? So, next is we compare po yung actual sa balance. Yan. So, we compare the moment actual comparing to the balance moment. So, actual moment natin, in-solve natin. Okay? Sa maximum moment sa beam is 230.4 and then yung balance moment natin is 182. So, as you can see, our actual is greater than the balance moment. So, we would say na it is a doubly reinforced beam. Okay? So, now, the question is how we will design a doubly reinforced beam. So, as you can see, if doubly yan, meron po tayong bakal sa compression, AS prime. Tama po ba? Okay? Then, meron tayong area ng steel sa tension side, which is AS. Okay? Or tension steel area. No? AS prime naman sa compression steel. Right? So, ito, ang kinakarga nitong doubly reinforced natin kapag nagde-design tayo is siyempre yung actual moment. Okay? Na kinompute natin kanina. Ngayon, So, paano natin siya solve? Basically, we can separate, no? Itong bakal natin dito na dalawa, no? Ito. Okay? So, this is equal to, for the separate diagram for a singly reinforced, yung maximum, no? Para maging singly reinforced design, plus yung additional po na reinforcement, okay? Dahil nag-add po tayo ng compression bar. Okay? So, balik tayo sa moment na kinakarry. Dito, ang kinakarry na moment po ng doubly reinforced. No? Ito is the M actual. Ngayon, equal siya ng pinagsamang M1 plus M2. Ano ba yung M1? So, M1 is the moment that the beam can carry as a singly reinforced beam. So, ano ba yung maximum moment na kaya niya carry para ma-consider na singly reinforced? Siyempre, yung M balance. Tama? So, your M1 here, okay, is the M balance. Yan, M balance siya. Ano ba yung M balance natin? 182.9. So, yung M balance, ito po yung maximum moment na kayang i-carry ng ating beam as a singly reinforced beam. As you can see here, no, singly reinforced po ito. Okay? Ngayon, as you can see, kulang pa itong 182.9 para makarga nyo yung actual. So, magdadagdag po tayo ng steel area. Okay, so we have here, in the compression side, AS prime. Okay, kung merong AS prime, so dapat merong kukontra sa kanyang tension. Kaya magdadagdag tayo ng additional tension area, which is the AS2. Right? So, ano naman yung moment na ikakarga nitong dalawang to? It is the excess moment. Okay? Ito yung kulang na moment. Or sobrang moment sa actual na hindi kaya ikarga ng ating M1. Okay? So, meron siyang value na M actual minus the balance moment. Right? So, that's the carrying capacity of each figure here. If you're going to add that, M1 plus MXS, it is equal to the actual. Right? So ngayon, paano natin siya solve? Una mong solve dito is yung AS1. Okay, so you're going to solve AS1 which is similar to the singly reinforced. No? Singly reinforced muna tayo. So, ang magiging M mo dito is the M balance. Kung paano mo sinasolve yung singly reinforced, ganoon na ganoon po. Pero kung ang M mo ngayon is the M balance, hindi M actual, no? M balance ang ilalagay mo. So, solve for AS1. So, we have here the formula for moment using the tension force. So, we have M1 is equal to T1. So, we're considering ito yung kino-consider natin muna. Unang pakialaman yung ito. Okay? Unang pakialaman yung sa MXS. Dito muna tayo. Okay, so we have M1 is equal to T1 tension force times the distance between the compressive force and then due to the concrete and then the tensile force due to our steel. So we have D minus X balance. Bakit X balance po ginagamit natin? Kasi take note, ito pong figure na to is under M balance pa rin. So, ibig sabihin yung X na lalabas po dito is nasa X balance. Okay? Gets po? Alright, so next is we substitute the values here. So, we have 182.9 as your M1, which is the moment balance, times 10 raised to 6 is equal to T1. So, ano ba yung T1 natin? T1 is equal to area times stress. So, which the area here is AS1. And then our stress is the Fs. So, yung allowable stress is 140. Kaya 140 po nilagay natin sa steel stress. Okay, so times natin ng D, which is 540, minus X balance. So, yung X balance, na-solve po natin kanina yan. 205.2 all over 3. Okay? So, next is, using this formula, we are now, okay, ready to solve AS1. So, AS1 is equal to 2770.20 millimeter square. Okay, so maliwanag pa. So, this is for AS1. So, yung AS1 dito, pag tinanong what is AS balance, siya rin yan. Kasi balance moment yung ating ginamit dito. Okay, and then also X balance yung ginamit natin. So, yung lalabas po dito is AS balance. Okay? Parehas lang po sa AS1. No? So, next is, after solving AS1, solve for AS2. So, ano ba yung AS2 natin? So, AS2 is ito po yan. No? Dito na tayo sa MXS. So, using the moment excess, okay, and then using the AS2. So, solve for AS2. So, MXS, ano ba yung moment excess? Okay, ilan pa yung kinakailangan natin, no? So, that is 230.4 minus yung moments balance. Okay, so moment balance. So, we have 182.9. So, 230.4 minus 182.9, we will have an answer of 47.5 as your MXS, or let's say this will be your M2. Tama? So, from this, the same formula po dun sa ating M1 and T1, we're going to use M2, T2 naman dito. So, M2 is equal to T2 times. So, meron tayong D minus D prime dito. So, D minus D prime, as you can see here, itong distance na ito kasi kinukuha natin for the moment, diba? Yan. Then, ito yung ating T2. Yung gusto natin, mag-moment tayo sa mismong compression steel. Then, we will have this force, which is T2 times yung moment arm. Ano yung moment arm natin? Okay, moment arm natin, as you can see, itong from here to the centroid of detention steel 2, this is your D, tama? Effective depth. So, ang kinakailangan natin dito is this height. So, that is the D minus D prime. Okay, and then let's put our values here. Let's substitute our values here. So, we'll have M2, which is 47.5 times 10 raised to 6 is equal to AS2 Fs. So, yung Fs po natin dito, kasi tension steel pa rin ito, is 140. So, we assume po natin na maabot nung steel, tension steel, ang allowable po natin. Okay? Explain ko na kung bakit yung tension steel ang pinapaabot natin ng allowable stress. Okay? So, 140. So, using this 140 here, times D, which is 540, minus D prime, 60. Bakit 60? Okay, so sabi dun sa problem, effective reinforcement cover, no? So, ibig sabihin, kahit anong cover, tension steel ba yan, or compression steel, para parehas po yung effective steel cover natin. Okay, so 60 pa rin. So, we have here AS2, which is equal to 706.85 millimeters square. AS2. Ngayon, ang total po na area sa tension steel or area ng steel sa tension is equal to the summation of all tension steel area. So, i-add mo lang basically yung AS1 plus AS2. Yan na yung AS total po natin, or area sa steel or tension steel, okay, which is equal to AS1 plus AS2. So, ang AS1 natin is 2770.20. Ang AS2 natin is 706.85. So, we will have a total area for the tension steel which is equal to 3477.05. Okay? And then, further, ang tinatanong po sa atin is yung number ng 32 mm diameter na bar. Ilang 32 mm ilalagay natin? So, N here, the number of bar is equal to number of bar, NB na lang, no? Para hindi tayo malito sa modular ratio, no? NB, number of bars, equal to AT, the total area of our tension steel, all over the area of one steel reinforcement. So, ang diameter na binigay is 32. So, area ng 32 mm diameter bar. So, lagay po natin yung mga values here and we will have an answer of 0.32. Okay, 0.32 piraso o pieces ng 32 mm. Pero, siyempre, okay, hindi po ganyan dapat ang final answer natin when we are solving for the number of bars. So, we need the number of bars in whole number. So, which is from 4.32, always round up. Okay, we have 5 pieces. Okay, 5 piraso ng 32 mm diameter bar. Ito po yung sagot natin for this detention steel. Okay, so next tayo class is dun po tayo sa compression steel. Okay, so sa compression steel naman class, okay, ang unang tanong dito is siyempre yung stress sa may compression steel. Bakit hindi po, okay, hindi ba Fs is equal to 140, sir? Diba? So, alam po natin, sabi ko dun sa naunang mga example, yes, the allowable steel is 140. So, hindi ka pwede lumagpas ng 140. So, ang tandaan po natin, okay, ay nasa compression side yung steel na tinutukoy natin. So, Fs prime ang kinukuha po natin. So, meaning, hindi po natin pinapaabot. Okay? Maliban na lang kung sasabihin ng question na kailangan ganito yung stress ng ating compression steel. Pero sa designing class, di ba? Sabi ko, pagka WSD, inuuna natin na dapat ma-reach ng ating steel ang sa tension ang kanyang allowable stress. Sa compression, kahit hindi niya ma-reach yun. So, dito, kaya hindi po natin alam, no? If, kailangan natin i-check if ma-reach ng steel, ng compression steel, yung allowable stress or not. Okay? So, paano natin siya kukunin? Yung stress sa compression steel, Fs prime. So, from the stress diagram class, if you remember the stress diagram. So, this is the stress diagram. Okay, yung nasa taas yung compression. So, Fc, yung maximum compression sa concrete. And then, at this point, meron po tayong stress din sa ating compression steel, which have a formula of Fs prime all over 2n. Okay? So, paano natin kukunin yung Fs prime? By similar triangle as you can see, Fc is to X balance. Mac, Fc is equal to X balance is equal to, or simply X, no? X po, Fc is equal to X. Okay, pero dito sa ating problem, dahil balance moment po yung kinuha natin for M1, okay, yun po yung ating magiging X balance, no? Is equal to Fs prime all over 2n all over X minus D. So, by substituting the values, so we'll have 9.45 as your allowable sa steel. As a concrete, no? 9.45. So, all over 205.2 is equal to Fs prime all over 2 times 9, 2n all over 205.2 minus 60. Okay? Back. Okay, so we have Fs prime is equal to 120.36. Okay, ito yung actual, no? As you can see, hindi niya po naabot yung allowable na 140. Kaya po sinabi ko, no? Okay? Kasi gusto natin yung steel ang unang makaka-reach. So, may instances po, class, no, na marireach na din yan. Okay? So, ngayon, if your Fs prime is less than 140, so ang gagamitin nating stress sa compression steel is, of course, the 120. Hindi po 140 kasi hindi niya na-reach. Okay? If na-reach niya siya or mas higher pa, let's say your Fs prime is 150. Okay? If your Fs prime is greater than the Fs, for example, Fs mo 140, ang Fs prime mo nakuha mo 150. So, the rule says, the code says, ang gagamitin mo pa rin, of course, the allowable, which is 140. Okay? For this problem class, your Fs prime is less than the Fs. So, we're going to use Fs prime. Hindi po 140. Ito yung sinasabi ko, no? Hindi agad-agad na yung Fs prime mo is equal sa 140 o yung allowable stress steel. You need to check using the stress diagram and using similar triangle. Okay? So next is, after solving Fs prime, we can now use or solve the As prime, area of steel in compression side. Okay, so gagamitin natin yung forces or yung force sa compression steel, which is C2. No? Yung C1 natin is force sa compression o compression force sa concrete. Yung C2 naman yung sa compression force or stress or force, should I say, no? Compression force sa compression steel. Right? Yun yung C2. Okay, C1 is a concrete, C2 is a compression steel. Tana? So, M2 here is equal to C2 times D minus D prime. Okay, tama? Alright, so yung M2 natin, yan po yung kinuha natin na excess kanina, yan yung moment ikakarga ng additional tension steel and additional compression steel. Okay, so lagyan natin lahat ng value. So yung C2 natin is basically, we have this formula, 2n minus 1 times As prime. Ito po yung transform area, tama? Times stress. So ang stress natin, based on our strain diagram or stress diagram, is Fs prime over 2n times the moment arm D minus D prime. So, lagyan na lahat natin yung value. Okay, so yung n natin is 9. Right? And then, Fs prime natin is 120.36. Ang D natin is 540. Ang D prime is 60. So, we will have an As prime is 870.55 millimeter square. Ito po yung ating As prime. Okay, or the area of our compression bar. Ang tanong dito, ilang 32 mm ang lalagay natin sa compression side. So, i-divide ulit natin yung total area ng compression steel divided by an area of 1 bar. So, we'll have an answer of 1.082. So, dito, mas malapit siya sa 1. Okay, but, of course, pagka nagde-design po tayo, ang minimum na number ng bar per side is 2. Kaya hindi po pwede na yung reinforced concrete mo, okay? Lalo pagka structural beam yan, no? Hindi po lintel beam. Kasi meron tayong tinatawag na lintel beam or meron tayong tinatawag na yung pang-cladding lang na beam na pwede siyang single. Yan siya. No? Yan. Okay, pero dito, sa minimum po natin 2. So, 2 ang lalagay mo. Ganyan dapat siya. Hindi pwedeng isa. Kung isa lang yan, class. Okay, makikita ka ba ng beam na ganito? Sa gitna lang. Okay, nandito yung 32 mm mo. Gitna. Then, sa baba, 5. Paano stirrup niyang class? Triangle. Of course. Okay? So, hindi po natin pinapractice yung ganyan. Kaya, okay, so minimum po natin pag ganito, class is 2. Okay, so say 2. Okay, and then 1.082 naman siya. So, talagang round up tayo lagi. So, 2. Okay, lalagay na. What if lumabas po dito is lumabas is 0.92. Say 1 ba? Of course, sabi ko nga, minimum is 2. 2 pa rin ang gagawin natin. Right? So, ito po yung sagot natin. 5 sa tension side, 2 sa compression side. So, I will explain briefly. Ito po, baka magtaka yung bakit yung sa C2 natin, okay, is merong 2n minus 1, saka merong over 2n. Samantalang sa tension force natin kanina is ASFS lang. Tama? FAS. So as you can see, transform area dapat ang nilagay natin. So NAS dapat, no? NAS for tension steel. Then yung kanyang stress is Fs over N, no? But as you can see, magka-cancel pa yung N. Cancel, no? So yung tension force natin is ASFS lang. Tama? Samantala yung C natin is kailangan mo siya ng transform area 2n minus 1 AS prime times yung stress niya Fs prime over 2. As you can see, yung pag-memorize na lang po ito. Kaya sana po na natindihan kung bakit merong nagkaiba yung medyo may pagkakaiba yung compression steel formula. Yung force niya instead of AS prime, Fs prime na lang, no? Nalagyan pa natin siya ng 2n minus 1 saka over 2n. Okay, so take note, ha? Okay? And then, discuss ko na rin din yung mode of design natin. So, this is the mode of design. So, yung mode of design natin, meron tayong tatlo. Meron tayong balance design, meron tayong over-reinforced design, and under-reinforced design. So, balance design, meaning, yung moment due to concrete is equal siya sa moment due to steel. Kaya tinawag siyang balance design kasi parehas sila. Okay, ng magiging value ng moment. Ngayon, meron tayong dalawa pa, which is the under-reinforced and then over-reinforced. Pag over-reinforced siya, mas marami yung bakal, mas marami yung magiging value ng kanyang moment due to steel. So, MS here is greater, or moment due to steel is greater than the moment due to concrete. Okay? Or due to compressive force ng ating concrete. So, MS is greater than MC. Over-reinforced po yun. Pag under-reinforced naman, mas malakas yung moment due to concrete. So, MC is greater than MS. Sa ibang salita, pag under-reinforced, mas kokonti po yung bakal. Na pagka over-reinforced, madami naman yung bakal. Pagka-balance design naman, sakto lang yung bakal. In actual class, we cannot achieve po yung balance design. Then yung magiging mode of design natin lagi. So, mode of design natin will be under-reinforced. Bakit under-reinforced? Kasi sabi po, no? Kapag under-reinforced daw, right? Kasi pagka nag-gild yung bakal, nag-gild yung bakal, kaysa sa concrete. Yun under-reinforced yun. Kasi mas unang ma-stress yung steel natin. Kasi nga mas kokonti sila kaysa sa ating concrete. Mas mahina kasi siya kaysa sa ating concrete. Kaya siya yung unang stress. Pag una kasi ma-stress ang steel, okay, magde-deflect mo na yan, magde-deform mo na siya. Okay, so meron siya mga warning signs na merong mga deflection, no? De-deflect mo na siya. So meron siyang, kung makikita mo, pag nagde-deflect siya, may warning na siya. And then you have time to evacuate the building. Pero kapag over-reinforced naman yung design mo, over-reinforced, mas malakas yung steel kaysa sa concrete. Okay? Or mas maunang, let's say, mas maunang mas stress yung concrete natin sa compression kaysa dun sa tension. Kaya alam natin yung concrete, hindi po yan bibigay ng warning. Nag-crack, biglang magka-crack na lang yan, no? So, ayaw natin mangyari yun. So, pagka over-reinforce siya, wala siyang warning glass. Hindi siya nag-warning. Hindi siya nagde-deflect. Biglang sasabog yung concrete. Yun po ayaw natin, no? Kaya ayaw natin ng over-reinforce, yung sobrang daming bakal. Nasabi ng ilan, mas matibay, mas maraming bakal. Pero no, mas delikado po yan. Ang gusto natin under reinforce, gusto po natin na ma-maximize yung strength ng ating steel. Okay? Mas safe po yon sa atin. Okay? Siyempre, wag naman yung sobrang under reinforce. So, isang bakal lang nilagay. So, ayaw din po natin yan. Meron po tayong limit sa code na we will discuss next meeting on the next method, which is the US. So, let's recap class our lesson for today. First, recap here is first recap. So, doubly reinforced, no? Doubly reinforced po tayo. First step, check mo muna, no? Check if your moment actual is greater than moment balance. Pag greater yan, of course, doubly descent po yan. Tama? Okay, so next is, after checking M balance and M actual, and if this is a doubly reinforced, so we need your M1 will be your M balance. Tama? And then we will have to solve AS1 using M1 is equal to T1 times D minus X all over. Okay, your T1 is equal to AS1 times Fs. Okay? Then meron tayong S1. The next is solve for M2. So, ang M2 natin is M actual minus M balance. Then now, using M2, going to solve T2, that is D minus D. Where your T2 here is AS2 times Fs, okay, which is 1. So next, after solving AS1, AS2, yung ating total AS is equal to AS1 plus AS. Then your N is equal to AS all over area of 1. So next is solving for AS prime. So AS prime, first check what is Fs prime. Okay, so makukuha natin Fs prime. Meron po tayong ginawa kanina. Tandaan nyo yung stress diagram. Gamitin nyo po yun, no? Stress diagram. Then next, after solving Fs prime, then if your Fs prime is greater than the Fs, so use Fs. Tama? And your Fs prime naman is less than our Fs, allowable stress, use mo yung Fs prime na actual. Okay, so after solving Fs prime, pwede na natin po makuha yung As prime, which is equal to, okay, gamit po yung M2 is equal to C2 times D minus D. Okay, where C2 here is equal to AS prime Fs prime times, of course, transform area to plus, so we have 2n minus 1 As prime times Fs prime all over 2 times D minus D prime for the moment. Diba? Kinukuha po natin yung C2, ito yung magiging form. So using this, okay, makukuha po natin yung AS prime. Makukuha po natin siya, and then makukuha natin yung N number of bar sa compression side, AS prime or AP. Then mode of design, under reinforce, if your MS is less than sa concrete, no? Then over naman yan pag reinforce design siya, no over-reinforced design, if your MS is greater than your MC. And of course, balance yan pag your MS is equal to your MC. Okay? So that's it, class. Thank you very much for listening.